All right, so next up, I'll talk about essentially monitoring, real-time monitoring, and then a little bit about incident response. So I'll talk about company or the protocol I work with, which is Forta. And the way, so Forta is essentially a decentralized network. It's not a blockchain. So think of a decentralized network that integrates with various blockchains.
That kind of make it the layer 2 essentially.
Nope, because it's not a blockchain. But it integrates with, it's similar to kind of the Oracle, the Chainlink Oracle network. Again, not a blockchain, but it integrates with blockchains. So it's decentralized and permissionless. So decentralized network that monitors transactions that occur on the blockchain in real time. So the way it works is you have a set of scan nodes. That's the decentralized network that integrates, let's say, with the Ethereum blockchain. As blocks get mined, these scan nodes kind of monitor that activity, and then they forward every block and every transaction to a set of detection bots that are developed by the community that include essentially heuristics or machine learning models that analyze that transaction for suspicious activity. And then if something is suspicious is identified, they raise an alert. So there's really two kind of main components. It's the scan nodes that forward these transactions, and then detection bots that contain the logic. And it's permissionless. So that means anybody can run a scan node. Now, why would you want to run a scan node? Because you make money doing so. There's essentially a stake that you have to put up, and then as you meet certain criteria, you earn rewards. And if you don't behave well, then your stake is gone. The reward, where that comes from, right now it's subsidized by the Forta Foundation, but eventually you have to think about there's okay, detection bots, scan nodes that run the infrastructure. Then there is the community members that develop the detection bots that then essentially generate threat intelligence, which is the network is really designed to generate. And then the third one is subscribers. So protocols that want to get these alerts so they're able to mitigate attacks that are in progress. Eventually, the subscribers will have to pay to get that intelligence. Then that payment would make it into the network and then gets distributed to the scan node operators, as well as the detection bot developers. That's right.
So the devices rank better programs and then also to pay for the service because they'll get better.
That's right. That's right. So that's really the crypto economic incentives that drive the behavior that you want to see on the network. And kind of the way the Forta Foundation is set up, Forta Foundation does not operate this network or really develop a whole bunch of detection bots either. But really, it's a shepherd of the protocol to create the protocol with these crypto economic incentives, so eventually it can run independently.
How can my fund get to this game? Okay.
How
does that work?
A good question. So basically, the network is integrated with the Polygon blockchain. So there's a set of smart contracts deployed on Polygon that take care of things like staking, rewards payout, registration of bots onto the network.
It's not a separate use Matic has to.
No, it has its own token. It's the Fort token.
On
It is on Ethereum, but it is bridged into Polygon. And so when you run a scan node, you have to stake Fort tokens, and your payment will be in Fort tokens. No, it is a much lower bar. I don't remember what the stake is, but I would assume it's like a few hundred US$.
Well, actually, that depends. Depends on how the sections.
You need to have at least a light node, because basically you need to see what blocks get mined and forward that information to the detection bots. But you don't need a full node.
So, but you are actually running them like an Ethereum node, scan node on top of it.
That's right.
So you could be running a full Ethereum node, a scan node, and monetizing both of those. Well, that depends.
Well, the Ethereum node, you don't monetize unless you do mining as well, right? But yeah, I mean, now with a validator, right? Yes, you could certainly do that. The
And right now, the subscriptions are right now, that's the phase of the.
That's right. So currently, kind of the network is subsidized by the treasury of the foundation. The Forta app is essentially the way you interact with the well, the Forta app is one way you interact with the Forta application, as well as it serves as essentially a block explorer. Now it's not a block chain, but think of it as kind of UI on top of the network. So you're able to explore network properties, as well as you're able to explore the alerts that the network emits. So let's look at the network here real quick. So currently it supports 7 EVM compatible chains. There is about 3,500 scan nodes that comprise the network, and several hundred detection bots that are deployed on the network. When you deploy a detection bot onto the network, it actually gets distributed to many scan nodes at the same time for redundancy purposes. So if one scan node goes down, you still have 5 scan nodes that essentially do your job, which I think is a very cool aspect of the network. You can search for bots. We talked about there's actually several bots that are deployed that monitor Tornado Cash, both on the funding, Tornado Cash account interacting, or money laundering are kind of the 3 primary ones. We talked about flash bots. There's a flash bot transaction, flash loan. There is a whole bunch of flash loan detection bots, and then what else is it? Well, that one is phishing. Bots. So essentially, these bots are all looking for a specific attacker behavior, and then you can also take a look at the alerts. There's a lot of alerts because the bots themselves are fairly noisy. If you think about Tornado Cash is not always associated with attacker behavior, right? But there's a bot that basically reports every single Tornado Cash funding.
Does the network have this construct of like that are doing ML on alerts?
Yes, and I'll talk about that.
Be careful how I ask that question. I was thinking like, so I'm asking this question.
So I mean, I kind of pulled up already a whole bunch of bots that exist that essentially look at the attacker behavior in each of these individual stages. And there's more and more coming, you know, every day. There's essentially a community that develops these detection bots. So
Centric for creation or proprietary?
you can do both, but basically what happens when you deploy a bot, it gets packaged into a Docker container that is then uploaded on IPFS. The language to develop the bots is JavaScript and Python. And so theoretically, you can download the Docker container, look inside. And so it's hard to keep proprietary. The feedback has been from the community, well, I want to protect my IP. And so there is going to be functionality on the network that kind of gives you private nodes that you are able to run with your own detection bots, and then it merely pushes exactly the alerts onto the network. Mark? They only get paid for running the infrastructure, so they're not the bots. So the scan node, basically when I deploy, let's say Tornado Cache bot, and you all run a scan node, I submit that to the network, and then the network says, okay, Mark, you're gonna run Tornado Cache, Duke, you're gonna run Tornado Cache, and Con, you're gonna run something else. And that's right. And so you get, as a scan node, you essentially get reward for uptime, for SLAs. But your question still applies to the bot developer. So you develop a Tornado Cache, I develop a Tornado Cache bot, and now we essentially raise the same alerts. Well, somebody needs to subscribe to the alerts, right? So if you have more subscribers than me, you should theoretically get more rewards. And so that also incentivizes a little bit more like marketing, right? It's not like you're just going to submit a bot and say, oh, it's good enough, right? You may have to advertise that, hey, you created this good bot.
What might fall positively.
Exactly. Yep. So let's run through a few examples so you get an idea on what these bots are able to do. So flash loans are super easy. It's a simple heuristic. It basically says identify all the transactions that obtained a flash loan. So it looks for flash loan providers like Aave, and then it assesses whether the transaction created a large amount of profit that you would usually not observe in the case of an arbitrage. That's the heuristic. That's right. And you cannot alert on every flash loan because, well, there's all these legitimate use cases for flash loans. So you kind of need to carve essentially, hey, these characteristics would be indicative of an attack. These are not. One is essentially the exploit transaction. And it could be that that is really too late. The funds are all gone. But you also have to think about that there's a situation today and the ecosystem may look very different a year from now or 2 years from now. If you think about contracts, they were immutable. There was no proxy pattern, right? Because basically people said code is law, and then they figured out, oh, there's actually an advantage of having updatable contracts. Something similar could happen on tokens, where you could have reversible tokens, right? Just like credit card chargebacks, right? You could have that concept going forward, or you could have block lists where you can freeze assets. Rug pulls, we talked about rug pulls. Again, similar problem, right? After the rug pull, the damage is already done, but you know, you should probably not continue to buy that token. And so there is detection bots that essentially use a time series anomaly detection on price. So it's essentially models or records the price over time, creates a time series model, and then basically alerts if it breaks out of normal range. And what this kind of illustrates is that detection bots don't necessarily have to make a decision based on one transaction alone. They're able to keep state and kind of reason on top of state. And the last one that I want to mention is exploit simulation. As I mentioned in the inverse case, right, we have the contract deployed. It's available on chain, and then a few blocks later, the exploit transaction happens. And so what that allows us to do is essentially fork the chain at the point when the contract gets deployed. We look at all the function hashes that are contained in the contract, and we start invoking them. And as we invoke them, we look at, well, are there large amounts of digital assets moved into the deployer or the contract address? And if that is the case, then it is very likely to be an attack. So you can simulate all of that locally. Now, it's of course a little tricky because if the parameters don't match on the function, or maybe I looked at one yesterday that basically had a require statement on every single function that says if the transaction origin is not the attacker contract, revert, right? So there could be protection mechanisms in the contract itself that makes it difficult to simulate. And now to your point, Colin. So there is essentially a layered sort of approach where you have a whole bunch of bots that, in a way, you have to think of it as they essentially give us a signal. But the signal in itself is super noisy. Tornado Cache, great example, right? If you learn on Tornado Cache, you're going to catch many attackers, but also a lot of legitimate users. And so what happens is alerts are consumed by a second layer of bots that combine them together in a way that is consistent with attacker behavior. So if you have an address for which a funding bot fired, a preparation bot fired, an exploit bot fired, a money laundering bot fired. You have a duck, thank you. And of course you want to be, I mean, ideally you want to be in the funding and preparation stage. That's when that high confidence, highly precise alert should be emitted. But even if you do it at the money laundering stage, and Colin, I love your point in terms of, well, you want to be informed. I can give you an example where that was not the case. The Ronin Bridge, $624 million were stolen, and it took them a week to find out. And I mean, the Ronin Bridge, they had $3 billion in the bridge. The attacker actually had an opportunity to steal $3 billion, but they only stole a little over $500 million. And the fact that they didn't notice indicates to you that, well, they didn't have monitoring. They didn't even look at the balances, right? That is like a Power BI dashboard. That does not instill a lot of confidence in kind of, and you know, I think at a certain point in time, you know, it's one thing if you just get started and you're managing a few $100,000, but if you manage $3 billion, it's crazy. Now, one thing that attackers have started to do is if you think about this chain, right, they could use one account for funding from Tornado Cache. Sorry, talk about Tornado Cache not today. And then they transfer the funds to a second account that then deploys the contract, and then maybe another account that issues the exploit transaction. And the only reason why they would do that is to kind of evade these systems. And so essentially what you need to start doing is cluster entities together based on transfer of funds, on age, things like that. And then once you have these clusters, or here you have two clusters essentially, then you can group the alerts again together and still have that detection logic. How do you determine what detection bots to author? And this is more a question if you have your protocol. So Mark, you have your lotto protocol, lottery. there's an assignment that I'm going to talk about next week, which is all about threat modeling, and we'll talk about threat modeling in more detail next week. You may want to threat model your application, right? You probably want to do that with an Oracle, because that it introduces risk. But basically, threat modeling been around forever. Web3, however, is not very familiar with threat modeling. And threat modeling is essentially a systematic approach to identify and prioritize risk in an application, or in this case, in a protocol. And as you kind of identify and prioritize risks, ideally you would want to mitigate the risk, but then if you're not able to mitigate the risk, then monitoring can be a good way to at least keep an eye out on it. And next Tuesday, we'll talk about threat modeling in more detail and go through an example. And then lastly, there is incident response. This is an area that is unfortunately also not very mature in the Web3 space, where many protocols don't have a process about this at all. They get the call when they get hacked, and then they're like, oh, what do you do now? And generally incident response, well, first of all, you got to be prepared and ready. That means you have training, you have communications channel, there's forensic readiness, you have kind of the right logs that you need in order to respond to an incident. You know who you need to call. This is particularly important in Web3, that is often handled by multi-sigs, where you have 5 developers and 3 need to sign a transaction before any action is taken. You need to know. It's a good question. I don't know.
What we use inside Microsoft for incident management.
Yeah, it's like an incident management system. I don't think so. Okay. Then, once you are prepared, then you need to have a process that help you identify whether you actually have an incident. So how do people reach out to you? If you use Forta as a monitoring solution, what Forta does, it merely gives you information. It does not tell you here's an incident, right? So it gives you an alert. And so essentially you need to triage and assess and triage the alert. And then you have to have specific characteristics to basically say, oh, now it's an incident. Then once an incident is declared, you need to identify the goals, work with the team and iterate on executing against those goals. And then lastly, after the incident has been declared resolved and the dust has settled, you should take a look at looking at what went well, what didn't go so well, so you can continuously improve your incident response process. Now, what I described here in general is kind of like a manual incident response process. If you think about 8 minutes in the inverse finance attack, from funding to money laundering, this is not going to work. It's going to take you longer to pick up the phone to call the people of the multi-sig to take action on your protocol.
Automated response those.
Develop automated incident response processes. But Mark, to your point, if there's a detection bot that raises a false alarm, then that could essentially lead to DDoS, right? If there's an automated incident response process that halts the protocol. Pausing the protocol also is a big hammer, right? There was a Twitter Spaces last week that we hosted, Forta. So if you look up Forta Twitter Spaces from last week, where the CTO of Open Zeppelin had a great analogy. He basically said the pause functionality on protocols is very similar to if a bank essentially shuts down if there's a fraudulent check, right? You don't want to shut down the protocol. You want to prevent the attack, right? And so pause is currently like shutting down the bank, and there needs to be more nuanced incident response. To kind of define this in the Web3 space on how incident response could look like It is not very mature. Also, you know, Web3 is decentralized. There's really small teams. Uniswap, you know, is probably a company of 20 people, right? They don't have an incident response team, right? And maybe they don't even have a security person. And so what is likely to emerge here is kind of service providers, just like auditing is done by smart contract auditors. There could be something like, hey, we're going to be your incident response team, MSSP like in the Web3 space. I think that is a much more likely scenario than teams building incident response capabilities themselves.
What are growing into that? Like, it's pretty